Welcome to the first of the Dirt Dude Conversations. I'm Andy Clark, and I'm here today with Bob Schindelbeck and Kirsten Kurtz from Cornell University Soil Health program. I'd like to welcome you both.
Thank you.
Bob he's an extension associate with the Department of Crop and Soil Science within Cornell. Has been involved a lot in the teaching and extension of the findings out there. Bob coordinates the soil health program laboratory operations and the development and I first actually saw Bob speak at the 2010 Australian Wine Industry Tech Conference in Adelaide, so I've known of Bob for quite some time. Kirsten is the manager for the Cornell Soil Health Lab, and also has experience in the wine industry in the Finger Lakes district, which is nearby to Ithica. Has run her own organic farm with, correct me if I'm wrong, garlic and small fruits, and is also an artist who loves to create paintings using soil. So has managed to sort of tie in a couple of her passions together with that. So if you actually look on the Cornell Soil Health website, I believe you'll see a few of your pieces online there, Kirsten, if I'm correct.
You are. Thank you.
So look, under the guidance of Professor Harold von Ess, Bob and Kirsten are sort of the 1-2 punch, I suppose, of the Cornell Soil Health program, and form quite a tight working unit to get the best out of this system. So welcome, and thank you for joining me today.
Thanks for having me.
Oh, pleasure. So the Cornell Soil Health program is renowned around the US and also the world for its holistic approach to sustainable soil. But are you able to tell us a little about the rise and development of the Cornell Soil Health program?
Oh, sure. Well, it began in 2003, in the early days of all this soil health and soil quality talk. There was kind of a movement, a swelling of people that were interested in getting a little more information from their soil testing. And we were invited to put in a proposal for a grant in the northeast part of the US to study this new idea that was, as I say, being formulated in its early days. And it was not yet soil health, it was still soil quality, sick soil syndrome, look at it from the other way. We were seeing very often soils, fields that were testing ideal for nutrients, yet the crop performance was very poor. And so growers knew that there was something going on that they needed to manage, but they had no easy way to test the soil to try to manage it. For example, compaction. It may be self-evident to some growers or to some people that, oh, that soil is compacted, but to others, particularly if the compaction is below the surface, it might be something that you might not think is going on out there, and in fact it is. So a group of scientists at Cornell, mostly with extension appointments, so they had a field bent to their science, were invited to discuss this topic. And as we discussed this, these scientists, we put together this proposal to study what we decided to call soil health from our perspective. We thought the soil quality was a more generic term. In fact, we borrowed from some early researchers that suggested that quality was something intrinsic to the soil and health was something extrinsic that you could actually change and manage. So in other words, if I'm a big boned person, I'm going to be large, but I can manage how healthy I am. I can manage that largeness, given that I am, quite a bit. I can do quite a bit about it, but there's things I can't do. I can't change my absolute size. So we wanted to apply that to soil. How could we get information from the soil to fill in some of the holes in our information? Of course, as researchers, I and Van Ness came from like a soil physics bent, if you will. We had some soil biologists, notably Dave Wolf and George Bowie, from horticulture and plant pathology, respectively. So that we brought this kind of a broad sense, the main players of the broad sense approach to wanting to get information all together. So each one of us had, with our own research, studied plant performance, but rarely together on the same field. And we thought, boy, if we could put all our heads together on a problem field, maybe we could do better. And in fact, that's the idea behind the test. We're taking the soil sample, bringing it back to the laboratory, and if you will, taking it to all of our different respective laboratories, getting the information, and putting it back together in a concentrated, holistic whole. Mm-hmm, mm-hmm. That was a big breakthrough for us, and it changed everything. We saw the analog between synergistic systems and these principles working ecologically in the field, as well as between ourselves. We also had to work ecologically together towards a common goal of better performance of ourselves as this team trying to solve this field problem.
Yeah.
And so analogies ran rampant, and so we developed all sort of human health analogs to soil health. And with that, we were able to kind of marry our different disciplines in this common soil ecology, if you will, but always careful to keep the different pieces separate, but always at the same time wanting to put them back together and respect their interactions. Mm-hmm, mm-hmm. So it's really been that was really the underpinning of all of our thinking since then. It's been some version of that. It's fine tuning that I would say that our vision was that nugget right there that we just we hammered on it quite hard at the beginning, and by this point we're kind of nudgingly tapping it along, trying to keep that ball afloat.
And how long a time frame did it take to come to this realization, I suppose?
It was fairly quick. We knew that there was a weakness to having the separation of the disciplines. But there's an old story where there's a corn growing in a field and it doesn't look good. So a plant nutritionist goes there and says, "Oh, you need nitrogen. The plant's suffering from a lack of nitrogen." And the soil physicist goes there and says, "Oh no, the soil's compaction. The roots aren't growing properly." The soil plant pathologist goes and says, "No, you've got a disease on the plant." And of course, all of these people can be right, and the soil is the system is upset. It's sick. It's unbalanced. But how do you then deal with it? If you ask any one of these people, they're right, but the solution isn't resolving the problem that they identified. Mm-hmm. It's typically a complex problem of all these things that are somehow interrelated. There may be plenty of fertilizer there, maybe too much, because you've applied enough fertilizer salt for a big crop for several years. You've gotten a small crop, and now these salts have built up, and you've caused this problem that you're unaware of. Okay. So we really wanted to put ourselves together without getting in each other's way, to be able to kind of tease it out, lay it flat, so you're not being blocked by the depth of interaction sometimes. Yeah.
Kirsten, so you manage the laboratory, so you see all the samples coming in. Now, obviously, you're based in Ithica in New York State, but you receive samples from predominantly, if I'm wrong, the eastern part of the US. What sort of differences would you see coming from different regions? Are there a lot of similarities, or what do you expect to see?
Yeah, soil is, as we know, highly variable. So there's lots of differences. We see a lot of differences with colors. Of course, that's one of the first things that I'm going to notice. We see a lot of differences with aggregate stability. We see a lot of differences with texture across the United States. And then I would say that those, because we do receive samples from all over the world, those soils are even more different when you move away from the continental United States. So it's highly, highly varied, and that's one of the really complicated things about what we're doing as far as kind of trying to advise people on management strategies. You have to have some awareness of what their industry is and what the background is. from the area so that you can give them some kind of a reasonable recommendation. Like if we don't know what their practices are and what they're doing on the field, we can't really say, oh, add manure or add this much N. I mean, we don't do that anyway, but we do talk to people personally on the phone and via email, and it becomes a very personal thing, actually. Like over time, you start to get to know various researchers, various people from all over the world, and you learn what their management strategies are, and then you're able to make more and more educated suggestions for what might help them.
Yeah. And so obviously you've, as I said earlier, you've had experience in the Finger Lakes wine district, which as an Australian coming to visit over there was pretty foreign, I suppose. Obviously there's a lot of cold issues you have in the northeast and the like, but what do you think makes the Finger Lakes district area unique, and also sort of what presents the great opportunity and challenges for it?
I think it's unique because we can produce really high quality wines in New York State, which I think it took the industry sort of a little bit of time to come around to that. We have a very similar climate to the Rhine River region in Germany. So we have a lot of really great successes with Riesling. There's a lot of challenges with climate, like you mentioned, but we have these incredibly deep lakes, the Finger Lakes of New York State, that help to temperate the area directly around the lakes. And most of the people who are growing high quality wine grapes are growing them on very steep slopes right along the lakes in very well-drained soil. Because we actually get quite a bit of rain in New York State. I think we get like 30 inches a year or something in that effect. So generally that's not really beneficial to growing good, vinifera grapes.
Does that include snow, that 30 inches, or is that just purely, okay?
It does. And that's pretty significant, but we have this, I'm a fan, of course, I love soil, so I'm really a big fan of this Howard's gravel that we have here that is extremely well draining, and that seems to lend itself to some really nice grapes. I have heard that it's been hard for our industry to get into good restaurants, just because we have Australia, we have France, we have all of these other places that are much more established, and really our wine region has only been active since the 80s in any significant way.
And you have, obviously the region is home to a lot of the Native American rootstocks as well, come from that area, and it was quite interesting to see them just climbing up poles and trees, the like, just wild, which I found quite fascinating. But you also have some hybrid varieties in that area as well, don't you? The indigenous to the area.
Yes, we do. And then a lot of the types of vinifera that we use, like the Riesling, that's grafted to more of a native rootstock. So that's how it's able to survive here. You wouldn't be able to just take Riesling from Germany and plant it here. It wouldn't survive.
Yes.
So they had to. It was Dr. Constantine Frank, who worked at Cornell University at the Geneva experiment station, who actually was the person who developed that technique and kind of made the discoveries that made this entire industry have the opportunity to, I think, come onto the world stage.
Yeah, great. So when I was fortunate enough to spend some time with the two of you and going around the Finger Lakes back in or earlier this year, and what I really took away from my time with you both and sort of chewing the fat, so to speak, was the fact that the program you have there at Cornell sort of gears itself around the paradigm of the farmer. So like we were discussing earlier, Bob, with the role of that sort of holistic approach and that ecological approach, and sort of you try to understand the paradigm that the farmer works in. Sort of, how did you sort of come to the approach that this would be the way that you'd go? What was the motivating factor in that?
Really, trial and great error. Right. When we first began doing this testing, this holistic testing, we got results back, and of course we tested it in the with the help of field staff and local growers that we knew. We tested kind of our results and said, well, what do you think of this? And it looks like you ought to do that. So we maybe because we're at the university, we kind of came with a strong set of ideas for how they should be managing better. And of course, the mistake you make if you're not careful is that you imagine any option you can dream up is something you can put on the table. And most growers, when you put an option on the table that is foreign to them, will let you know pretty quickly that you're likely to part ways. Farmers really want to be respected, and they deserve to be respected. And you need to, again, temper your suite of options if you're going to enable a person with options. You want to know who they are first, so that you don't offer things that are nonsense or very unflattering to them. They might not have these capacities to do certain things, or the desire, or literally the capacity. So you need to know who to truly help. You need to know who your client is, so that you can offer advices or strategies to get them to these small steps, leading to, of course, greater movement in a direction. So yeah, it was those were some hard lessons, but we took them well, I think. We really reversed things and said and recalled and now put forward that the person at the top of our focus has to be the grower and their set of desires. And when you consider that then you know which suite of options to begin to open and start with the grower on these different on the different pieces of plausible opportunities. Because while on campus we love to talk about wild and exotic things we've all learned and heard about, grower doesn't necessarily want to hear that.
Yeah,
necessarily.
Yeah, and I think it was during this time that I sort of started to realise that despite you think about soil science and it's a highly technical aspect, and obviously clearly with the range of the suite of tests that you actually do within a laboratory, it is, but it's that the decision-making process that goes around it that sort of it overrides everything, because we're not working in a natural native environment where it's a farm is a highly engineered system that you're creating. So it is that it's as much sociological as it is technical soil science. So I guess have you had a lot of pushback with how you operate it then, or are you getting a far greater response now?
Well, certainly now there's what you would have to call a soil health movement that's I don't want to say it's taking over agriculture in the U.S., but certainly those are the that's the two-word buzz of the last couple of years. Like a World Soil Day, the first World Soil Day was in 2015. And that really almost coincided with just soil health becoming in the national lexicon of things that people heard about and began to understand what we had been missing before, when we perhaps were a little more inclined to treat the soil like dirt. We know we wanted to treat it like the soil that it is and give it the respect that for the resource that it is. Because we harm it at our own peril.
Absolutely.
And the climate irregularities that we see, the best way to prepare for those, just as a person would, your health is your strongest asset, and the same with the soil. A balanced soil that's well functioning, more resilient through times of excess water, excess drought, and that's the big idea. So rather than so long we focus on maximum yield, kind of an American construct, I think, is always the maximum yield possible. Squeeze every bit you can out of that. Instead, we relaxed that a little bit and no, let's get maximum profitability without such intense hard use. We can sustainably garner good income from this land without beating it to death.
Yeah, we need to start using the word optimize rather than maximize, I think, in how we're managing our farming systems.
Right.
Bob, one of my my favourite quotes I took from my time with you is that it's the success of the pioneering farmer that draws the skeptic to the waters. How do we, with obviously those passionate about soil sustainability and the like, how do we nurture future leaders and champions of soil health? And I guess what examples can you share from your area, the Northeast there?
One thing I would say is that one thing I have noticed through all this is that people learn by example. You can talk about new ideas, and there's a certain kind of person that can think in their mind and build great models in their mind. But farmers tend to be of the more practical sort who, when they see a machine or a system operating with physical parts, they see that, they understand it, and they understand, wait, I can make this, I can optimize this, I can make this better. And these are your growers that kind of jump out ahead. And when they hear of these new ideas that they can grab onto and tweak a conventional or a standard practice, make it just a little bit more useful for themselves. You see other growers noticing that, saying, oh, wait a minute, if you can do that, I can try that. And then their soil's a little different or their crops a little different. So they take that idea and engineer it just a little bit differently for their needs. And it becomes a contagion where these ideas kind of pop up and they become almost standards. One example would be something like the key line ripping shank. We saw that come out here in the very late 80s, this idea of deep ripping. A shank, a fairly narrow cast iron shank that could travel up to almost half a meter, 18 inches into the ground. We pull around on this same width as a corn row, for example, multiple of these across a tractor, depending on its size, and kind of open up the soil. It sounded like such a great idea. We had a lot of protection from the bigger machineries that were being developed in the 80s, four-wheel drive. And we see that still as that sort of equipment is still around, but it's been built on so tremendously. There's all sorts of extra hardware hanging on those shanks now, before it, after it, to the side of it. But it all started with that little idea that someone saw, and they modified it. So to me, it's getting those early successors or people that are showing success and initiative and making something work at whatever level. They've found a way to fit that in. Then someone else is going to see it and say, I can make that a little wider. I've got an idea. If I use a slightly different cereal crop, I might be able to do that even better. And sooner or later, till things move in the right direction, they sort themselves out. There's such a variety of different arenas and fields and topographies and climates, microclimates even, that people find these ways that just work. And right in the most crazy places sometimes that have application in another area, that's when to me, you see those great light bulb moments. You can really say we're getting somewhere. There's hope for us.
Do you as the university or with your county or regional officers, do you have the capacity to sort of share their learnings? Is there any sort of facility within that in your region?
Oh yeah, very much so. We have it's called the extension service is the word we use to extend information from the university. We're in a what we call a land grant university situation here. Many of the early states in the U.S. Were given land and this charge to, with federal support, to develop ideas and support for the farmers of each of these different states. So money was given and land was set aside for them to do that in perpetuity. And so that's kind of where this idea came that we're working for the growers of our state. And we need an arsenal of field staff to do that. You can imagine back 50, 70 years ago, there wasn't a small army of staff running around the fields, sampling, advising, developing all the wonderful agricultural systems that we have. but as time's gone on, that's been reduced more and more and more. Yeah. The digital age, of course, allows for all sorts of outreach materials by the web. We have at least a yearly meeting for all of the staff from this state come back to Cornell in the different disciplines. They have a big meeting where they hear the latest things in the field are discussed, the latest things coming out of the research are discussed, and how they interface. And of course, at any time, when the field staff sees something, they post it up and say, specialist in this area, if they don't know the person, help. And they put nice pictures of a new weed or some disease. I saw an email today of a disease that someone spotted on a leaf. Said, I don't recognize this. Is this what I think it is? I'm scared. And someone else comes back and says, oh no, you don't see that often, but I know just what that is on that plant. Yeah. And so it's interesting how there's just so much information in a relationship like that, when you've got the campus being the backstop, if you will. Very, very focused, and then the folks out, doing that legwork, but of course finding all those very interesting things for the researcher then to help with and be part of.
Yeah. So just one for both of you, I suppose. I mean, obviously soil is, as you said, Kirsten, it's highly variable, and from in one paddock it could change numerous times over. But broad sweeping statement. What do you think would be three things that farmers or land managers could do in better managing their soils? They should be mindful of.
Cover crops, keeping the soil covered, keeping it protected. I think that's got to be one of the most important things, just because of building up the organic matter, and just reducing the erosion potential. The erosion that's happened on our planet has been pretty extreme in the last 50 years. And to me, that's the number one thing, is controlling that erosion in a lot of different ways. But I do think that we've made a lot of movements in that way, actually. Like a couple, even 5 years ago, to see cover crops was pretty rare. It was really just the really progressive farmers that are now the leaders in New York in the farming movement. But now I would say that most farmers possibly even use cover crops. Not sure if you agree with that, but it feels like it on our end.
Yeah, cover crops is just, the living soil, I think, is what the public really hears when they think of soil health. They think of this, it's a biome now. It's not just dirt that gets on your pants and dead. It really is alive. It's teeming with, the earthworm is always the champion of that life in the soil. But I think, what we've really come to realize is when we, on arable land in this part of the country, or northeast, or so much of the U.S. really, you've got less than half of the year. Here we have what I say about 140 days frost-free, and that's where we grow our main crop with arable land, with plowing, for example. So the land would be green once that crop is up, and then when it was hard, as it's drying down before harvest, it's browning. So there is then it's finally harvested, and the rest of the time the soil would be bare and not being actively fed with fresh carbon. And we find with pastured system, you've got, call it the full year, when as soon as the soil temperature is appropriate, there's plenty of activity going on, and maybe even when it is frozen surface further down. So we needed feeding the soil, and with the cover crops, we're able to get nearly a 50% more coverage in a given year when we're growing our main crop. And I think the hardest thing to do is to take something that you put all this effort into for so many years of this single crop season, getting as much as you can out of that, and now saying, well, wait, on either end of that, before we can actually plant our main crop, we could have something growing that could be feeding our soil, building the soil for this crop that's about to come on it, or that's about to. And I think that's a very exciting thing for someone interested in a living soil, because it's keeping the soil not just covered, but covered in terms of erosion and wind loss of soil, but also for the idea of feeding the the activity of the soil. Fresh food is needed by any organism. We don't, right, maybe we don't want our soil to hibernate all winter. We want it to slowly keep burning through its processes, preparing for the next big season when we're going to take advantage of all that work that these creatures have done for us, if we can manage them. Wouldn't that be nice if we could do that? And that's, I think, is a lot of the organic growers they're very keen on that idea of, hey, I need to get, I need to give. And I think this cover cropping is kind of that idea that I need to give back a little to get more out. And that I think it fits kind of this paradigm of getting away from just forever taking and maximizing the return, instead sustaining and optimizing the return.
Well, and as you said earlier, where you're one of the major issues in the initiation of the soil health program was the fact that you have all these numbers that in your test results that don't really show up, and a lot of that comes back to certainly what we see in Australia is poor soil structure, and it's the structure that the cover cropping can almost help more with than anything really. Sort of gives the soil that framework, and if you're dealing with only 140 days frost free in a year, it's not a long time. So you've got to make every other day outside of that count as much as you possibly can to reduce those compaction issues that you spoke about as well. So look, I think certainly you're preaching to the converted on that one. I'm not going to deny it. Is there anything else that you really think is worthwhile, or something that should be really top of mind other than cover cropping?
I would say compaction. Also, I think compaction's a really, really big deal. It's getting better as we've moved into no tillage. And when I first started working with soils, that was a pretty radical idea, like reducing tillage or no tillage. I think there's a lot of promise with the movements with digital agriculture and these concepts of always like driving on that exact same space.
The travel rows.
Yeah, in addition, which you guys have a little bit of an advantage with actually with the vineyards, but and then also just not going out on the field as little as possible, or maybe doing more than one thing while you're there. Don't go out and till and then come back and plant. There's a lot of things have changed as far as technology goes that can help us to reduce that tillage, because I think tillage is a extremely huge issue, over tillage rather.
Well, tillage costs a great deal. It costs a great deal as a grower. It begins with the machinery and the fuel and the time to run that machinery, and then the wear and tear on the machinery and that wear and tear that the machinery puts on the soil. It's undeniable. There can be a positive benefit from that. Of course, we know that that's how man has, in a way, subdued the earth. It's with this tillage. It's a very useful concept. It will probably never go away. But certainly the bigger growers are ever searching to get bigger, and the way they get bigger is by traveling across their land fewer times during a crop. And one of the ways to do that is to install the seed in one pass across the field and be able to realize as good of growth and a full yield from that one trip across the field versus a person has to go across many times. First, denuding all the cover of the field by covering that and flipping it over, and then with the moldboard plow, and then of course going back over the soil to re-flatten it, re-smooth it, recompact it back to a place where now you can plant. That cost and time to do that work, and the timeliness of it. The day that you could plow, you could be traversing almost certainly equivalent land in terms of speed, putting seed in the ground. But to do that in a way that's as reliable yield-wise and plant growth-wise takes not just talent, but technology. And I think we're seeing that now in the equipment, certainly the digital swathing techniques to keep things aligned, and to know where you are, and auto steer, some of these small but not so small features of the digital movement, which the equipment itself is capable of traversing across the field in a single pass. removing debris as necessary, smoothing the planting area, placing the seed appropriately to get good germination and a good stand, without necessarily, right, so preparing a very nice seed bed where it's necessary, but where the seed bed isn't necessary, try to do as little disturbance there as possible. Let the soil be held in place by decaying roots, and leave that area undisturbed so that you're not, so it's less vulnerable to action from raindrops. More machinery passes, because there are fewer. I think the no-till as a time saver as well as soil builder is desired by everyone, but in a way that is the golden ticket. If you could no-till your field, if your soil was so good that you could no-till it, if you managed it in such a way, that would be wonderful. And I think a lot of folks find themselves in a position where, were they to throw away the plow, just begin no-tilling because they've heard it's good, it fails. Soil just isn't prepared. We use a term called addicted to tillage. It's an old phrase now, but that does happen where a soil it's just so naturally compacted, it's lost a lot of its structure, that if you do fluff it up, pack it back down carefully with great skill, you can get an average yield. But if you can do that, if you can accomplish that with just a single pass, wouldn't that be nice? But it's something we argue that you have to work towards.
So how do you break that cycle?
Right. You have to build towards getting away from the plow. So you wean yourself off the tillage by doing maybe less of it or less intensively. Then eventually the goal is this no-till. Because the reward, when these long-term no-tillers speak, they're semi-gods because they're able to do so much. When you hear about the tremendous areas they cover alone, some of these growers, it's really impressive. And the other growers, they shake their head and say, boy, I wish me and my 12 sons could do all that work.
Yeah.
And the money I could make if I could do that. So it's something that I think the growers do understand that it's to be able to do it, it's something to be proud of and something to work for. And then when you can do it, you're saying, yes, I'm no-tilling about half of my acres now, meaning I'm getting my soil back into condition or actually have that option.
Yeah. Great. Look, with people such as yourselves that are sort of leading the way in the soil health program and the like, I'm really positive about the future of soil sustainability. So, look, Bob and Kirsten, thank you so much for your time this morning my time, but I really appreciate it and all the best.
Thanks.
Thank you.
Thank you.